eigenvalues and what are eigenvectors in this topic. Before we see that, we must understand what is the purpose of eigenvalues and eigenvectors. Now, these eigenvalues, these are basically, they provide a summary of the large matrix. Now, in real life situation, whenever we do such kind of any calculations, we do have a very large number of data sets and very large data. Now, these data may sometimes contain zeros. Now, these zeros have no real values. Suppose this is sparse matrix. Now, as you can see, there are so many zeros over here. The only values which are relevant to the computation is these values. So, in order to judiciously utilize the sparse matrix, we use eigenvalues and eigenvectors. Now, these eigenvalues and eigenvectors, basically have the main information related to that matrix, and these are used in specially for, suppose we want to find a relationship. As an example, let me show you. Suppose I know a value 2. Then what is 50? 50 is 25 times of 2. What is 100? 100 is 50 times of 2. So we are not saving these data. We are not saving these large data of 50 and 100. What we are doing is that the data which we already know, we are just scaling the data. Similarly, if I know 50, this is the starting 50 value, and I tell you what is and I want to save this 2, I will not save it as a 2. I will tell him that it is 50 divided by 25. So scaling is easy. Whether I multiply or I divide a value, the scaling is easy. And once we know that our core value, we can easily have a scaled value of that. So this is the basic purpose. So eigenvalues and eigenvectors are basically used in order for compression of the data. As I told you, my data sets, the real life data sets are very large. They will contain large number of sparse matrices. There will be large number of noises. We are going to eliminate the noises, and we are going to only have the real values. And this can also be used these are also used by search engines in order to rank the items, because obviously on the search engines also, these are all data sets which will have relevant information and irrelevant information. They keep track of the relevant information. So this is the basic idea why we need to do eigenvectors and eigenvalues. So let's see with an example how to perform it. Suppose this is the theory part, how to do so. You basically need the characteristic equation. Once you have the characteristic equation, you can easily calculate it. Let's see an example. Suppose I have this matrix, a 2 by 2 matrix, and I want to find out its eigenvector and eigenvalues. Now the procedure will be same for your 3 by 3 matrix, 4 by 4 matrix, 100 by 100 matrix. Doesn't matter. As long as it is square matrix, this method will work. So first of all, we need the characteristic equation. What is the characteristic equation? A minus lambda I. What is lambda? Lambda is basically your eigenvalues. So this is a scalar quantity. Lambda is a scalar quantity. What is I? I is an identity matrix. I believe you know what is an identity matrix. So it will just have values in our column. In the diagonals, it will have 1 in the diagonals. The rest values will be 0. It will have 1 in the diagonals. Now since my original matrix is a 2 by 2 matrix, so my I is also a 2 by 2 identity matrix, and when I multiply it with the scalar quantity, only that value remains. So I have for the characteristic equation, I get this. A is my original matrix, and this is the lambda I part. Then it's simple, just you do the matrix calculation, and then you have your eigenvalues. So this is the eigenvector. So for 2 by 2 matrix, I am having a 2 eigenvalues. Now from these 2 eigenvectors, you can select one at a time and find out the eigenvectors. Let me assume that I am taking lambda is equals to minus 1. So let me just consider on the left hand side. You have your characteristic equation. In place of lambda, now you will be putting your lambda 1 value which you have already calculated. So just put that value. It was minus lambda, it was minus over here, it is minus 1, so it became plus. So it's considered on the left hand side. We did the row transformation in order to find out a relationship between x and y. Now once we have such kind of relationship between x and y, you see it is just a k times of the values. So basically what is my x? My x is 2 times of k, y 2 times of k. Now this k can be anything, it can be 1, 2, 3, 0.5, anything. Depending upon the value of k, you can have multiple scaled eigenvectors. It can be multiplication divisions. As if I put 1 over here, k is 1, then x becomes 2, y becomes 2. If I put k as half, then my x becomes 1, y becomes 1. Similarly, if I would have taken my eigenvalue as 6, just see over here, I have just replaced the lambda with 6, and I have calculated, I've done the rule transformation in order to find out the relationship between x and y, and here my x and y is having a relationship of 2x and minus 5x. So similarly, you can have multiple number of eigenvectors which are scale vectors. So basically, this is the real information, the main information, and these are the scale information. So as I have already told you, what is the purpose of eigenvectors and values? The purpose of the eigenvectors is number one, in order to find out the relationship of two variables. How? Meaning at what times, how many times my one variable is related to another variable. So that is one relationship. Second, in order to provide a summary of the large matrix, eigenvalues and eigenvectors, they take out the important information from the matrix, or reducing the noise. So with this we have completed eigenvalues and eigenvectors.